So t is our independent variable, and we can just give you some examples to explain it further, and to find the domain of the function. And I have discussed before already the domain of the real value the polynomial function is a real number. Domain of the rational function f upon g, where f and g are polynomial function, is the domain where they all are defined, but g is not equal to 0. When you have the root function, in the denominator we say only bigger than 0, in numerator we say bigger than equal to 0. I give you some examples how to find the domain of the vector value function. Example 1, we are given here the vector value function r of t that's equal to 3 plus 2ti plus 1 minus tj plus t square k. So we write the parametric equation of our given function, given vector value function. We having x is equal to f of t, that's 3 plus 2t. Then we having y, and our y is equal to root of 1 minus t. Then here z, our z is equal to root of t square. So I can just write here t square. This x, y, z, we can just replace them by f of t, and this is my f of t, this is my g of t, and this is my z of t, h of t. So I use this function. I am going to find the domain of these, each of them. So we are having here the domain of the function f of t, the domain of the function f of t is are real numbers. Why? Because our function f of t is a polynomial function. So your domain of the function is our real number is minus infinity to plus infinity. When I find the domain of the function g, so domain of the function g is 1 minus t bigger than 0, or we can write here minus t bigger than or equal to minus 1, or we take t less than or equal to 1. So that will be here from minus infinity. Here we can have the open interval, we are less than 1, so we can write this one as minus infinity to 1. So that's here domain of g is equivalent to having minus infinity to 1. Again, h of t is our polynomial function. So I write here domain of our h of t, domain of the polynomial function here, like this one, this is a polynomial function, this is also polynomial function, is our real number, that's minus infinity to plus infinity. When I want to find the domain of the function r, so domain of function r will be the intersection of the domains of the function. Here we can have domain of function f, intersection with domain of function g, intersection with domain of function h. So when we take this the intersection of these, we get here this minus infinity to 1. So this is our domain of function r. I take another example. Next example is that we are given here the function r of t, and our r of t given to us is in the form of the values. Here r of t is defined as 3 plus 2ti, and then I am having here is plus 2 plus tj, and plus we having here k. Now I can again, as before, I just defined my parametric equations. This my f of t is equal to 3 plus 2t, my g of t is equal to 2 plus t, and h of t is equal to 1. So these all functions are polynomial functions. And if they are polynomial function, then domain is from minus infinity to plus infinity. So domain of f of t is minus to plus infinity, domain of g of t is minus infinity to plus infinity, and domain of h of t also minus infinity to plus infinity. Now I want to find domain of r, and domain of r is domain of f, intersection with domain of g, and intersection with domain of h. So as they all are having the same domain, so our intersection will be also from minus infinity to plus infinity. So this is my domain of the function. So this means the functions are defined, r of t is defined, and then the domain minus infinity plus for r real numbers. So that's the idea regarding the domain. And move further, that we can sketch these functions also. I take an example for this one. For sketching, I will say we can show the graph of this function. We can sketch the graph of the function. is my 11.2. When we want to sketch the graph of the function, first we have defined the functions in terms of x, y, and z, and then we can see how we can sketch the graph, or we can describe our function. We can say what this function represents. So I take an example for this one. This is my example 3, and I am having here the function. Want to describe the curve. Describe the curve defined by the vector value function. The vector value function we are having here, this is r of t. R of t is the function 3 plus 2t. And I'm having here, this is 1 minus t. And then I'm having here minus 2 plus 4t. So this is my vector value function that's given to me. I want to show what is represent. So I write my solution of this one. So for writing the solution, I first write my equation in a parametric form. So I write parametric equation of the curve. Parametric equations are the given vector value function. So we have here our x. Our x is equal to 3 plus 2t. Then we have y. Y is equal to 1 minus t. Or z equal to minus 2 plus 4t. Where t we can see here, these are the polynomial function. Then as I told you, the polynomial function, the domain is r real numbers. So I say t is my r. So if we look at these equations and we just go back our knowledge in the vector we have just studied, that's the equation of line and plane. So this is our equation of line. We know that, remember the line, we have the point and we have the vector. So we say this equation of the line is a line passing through the point. This is my x0, y0, z0, and this is my component of the vector r. This is r1, r2, and r3. We having here, this is the passing through point. The point is the value x0, y0, z0. This 3, 1, and minus 2. And as told there, when we are discussing the line, when we put here t equal to 0, we get this point. So then we having a parallel to the vector and parallel to vector r or a, and the components vector are 2, minus 1, and 4. This is the idea that we having, looking on the equation, we can describe that what is represent. This represent a straight line. If you want to sketch this one, we can sketch also this one. Just we can have the points. If there are the point, we can just write the sketch. So we can have many points on the line, and for each value of t that's in the domain. Domain is r real number. We can get the point of none. For example, I take here t equal to 1, t equal to minus 1. The point I'm going to get here, t equal to minus 1, we get the point is 3 minus 2, that's equal to 1. And here 1 minus 1 become here plus 1 become 2. And then I have here is 2, and then take minus 1 is minus 6. When I take t equal to 0, we get another point. When t equal to 0, we get here 3, 1, and minus 2, as I described before. When I take t equal to 1, we get another point, t equal to 1, 3 plus 2 is 5. Then 1 minus 1 is 0, and minus 2 plus 4 is plus 2. And so on. We can get, we can say we can find infinite number of points. For each value of t, there is a point. We know when we want to sketch a line, we need only 2 points. So I take here, this is my z-axis, and this is my x-axis. This is my x-axis, my z-axis, and it's my y-axis. This is my origin 0. I'm having here the value, I take this point and sketch this one, 3, 1, and 1. So x value of 3 is 1, 2, and 3. Then y value is 1, this here is 1. And then we having z value is minus 2, this is 1, this is minus 2, this is 1, this is minus 2. So my this point is 3, 1, and minus 2. So this is my point. So this is my z-axis. This is my point. Now I take the second point. This my point is 5, 2, and 0. I just change the color and just sketch this one. This point is 5, this here 4, and we are having here this has 4, and this is 5. And then is 0, 0 is the same one, and then 2 is this one, this is 2. So this along z-axis, this point is 5, 0, and 2. So this is a point, and this one is a point. So we can write here the equation of the line passing through these 2 points, and we can have here this is my line passing these two points. This is my line. So this equation of the line, this is here we say this is the line passing through these 2 points, and we can show it here. This is my line. So this is how we can sketch the graph of the function. This line, the equation is given to us here is the equation of this one is parametric equation 3 plus 2t and 1 minus t and minus 2 plus 4t. This is my equation. I take another example different from this one. This was example 3. Now I'm going to show you. I'm going to take example 4. So example 4 is, in example 4 we are given here the vector value function r is equal to 2, 4 cosine t and 9 sine t. So we want to describe this curve. What does this curve represents? So we write always the parametric equations to understand more. So we write here our parametric equations are we can write here the corresponding parametric equations for the given curve. So this my x is equal to 2, my y is equal to 4 cosine t, my z is equal to 9 sine t, and we are given the domain is only positive real numbers and 0. So here we given this one, and we know that we can solve this one, especially this y and z. So I can see here my cosine of t is equal to y upon 4, and my sine of t is equal to sine of t is equal to z upon 9. So I have here the trigonometric identity. We must remember these ones. These are very important trigonometric identities that help us to solve the problems. We have here sine square t plus cosine square t is equal to 1. We are doing the applications also. So we can put the values. We are having z square over 81 plus y square over 16 is equal to 1. So what is this? This is my ellipse. So I can say that the graph, the r of t represents, r of t describes an ellipse in plane x equal to 2. So this ellipse is in yz plane. This here is described the ellipse in plane x equal to, this is x equal to this my yz plane parallel to this one, and we can say this x equal to this yz plane. I can just describe this one. This is my z axis, and this is my y axis. This is my z axis. Now I am having here this is my x axis. This is my x axis. It's 0. This here is 1. This is 2. Now when I take this one, I can define here at 2. I can have here this is my z axis parallel to z axis, and this is my y axis. This is my here y axis, and this plane we are having here, plane is x equal to 2. These all values are in x equal to 2. Now in this plane we define our ellipse, and the ellipse is having the major axis. This is value of c equal to 9 and b is equal to 8. So having c 81, c is equal to 9 and b is equal to, we are having 16, and this is equal to 4. So this we are having here, this is our 9, this is minus 9, and this is 4, and this is minus 4. So I can just sketch my ellipse in this case, and I can say this is my ellipse. This here is, we are having here ellipse. This ellipse is in the plane x equal to minus 2, and this is my, here the value of x is equal to 2. At this point we can say here this my value is x equal to, this point is 2, 0 and 0. This point we can say here this point is 2, 0 and 0, and this gives me the sketch of this function r of t. R of t was equal to 2i, and then we are having here the value 4 cosine tj plus 9 sine tk. So this is sketch also, and we have described this one. That's the description, that r of t is an ellipse in yz plane, and we have seen this one. This is my x equal to this plane, and then in this one we have the z and y axis. This plane is the yz plane. This is our yz plane. We can say this is our yz plane. X equal to 0 is the plane here, yz plane, and then it's parallel to yz plane. We have 2 units out from there, and then we can just sketch the ellipse on that one, and that describes this our equation.